Hey folks, Mash here. I'm going to be doing some past paper revision with you folks, so I'm just going to be going through this and crossing my fingers. I'm doing this in one take, so this will probably go horrifically wrong, but hey, oh, what can you do? So 70 marks and all, and it's only, how is it? It's not that long, so don't worry. I wouldn't worry about this paper. Worrying will actually just make it worse. So you know, go on, hold your head, it'll be fine. So question one, they like to have the easy questions at the start, so you get to pick up quite a few marks at the start. Question one, I'll write this down. You're gonna have to excuse my horrific handwriting because I'm doing this through the medium of Microsoft Paint because I'm really lazy and can't be bothered to do it on paper, but there we are. So find the x coordinates of the stationary points on the curve with equation y equals a half x to the fourth minus 2x cubed plus 6. Okay, well, let's break this down. So stationary point, that is just a point when the curve doesn't move. So I'll draw a quick thing here. I've got this graph, got this cool curve. This point here, the curve isn't going up or down. It's just level, right? Same as this point here. But like this point, oh my god, it's going down. In other words, the gradient of the curve is 0, and that's how we're going to be able to figure this out. Because remember, when you take the derivatives of something, you're actually figuring out the gradient of that curve at any given point. And yeah, it does sound like a bit of word down, but it'll make more sense as we go through. So what I always do, this might just be a me thing. I always write down the equation I'm trying to figure out first. We'll see how many pages we can get out of this old thing. So you're gonna have to excuse my terrible handwriting. It's somehow worse on paper. This is actually legible at least. But to take the derivative of something, I can already see we need to make sure that everything's in power form. But we're all solid here. This is a 4, this is a 3, this is a 2, and then there's no like powers over powers under a fraction or anything weird like that. So we can continue on as normal. Well, so it's y equals something. So we're going to do dy over dx equals. So first term, what you do when you take a derivative of something, all you do is subtract 1 from this power. So in this case, it'd be 4. Actually, sorry. Mess that bit up. So what you do is you times the power by this, right? We get 2. Because 4 times a half, that's 2. Then we subtract 1 from the power. So change it to red here. You all know what 4 minus 1 is. It's 3. And then we just staple it back together. So that'll be x to the cube, 2x cubed for that. And then we just continue as on for the next term. So minus 2x cubed. You times the power by the, we call this the coefficient, which is just the number timesing the thing. So minus 2 times 3, that's minus 6. Then we subtract 1 from the power, cx to the cube. X to the squared, sorry. And then, funny thing about derivatives, we delete any what's constants. And this may seem counterintuitive, but the reason is that 6, that's technically times by this, right? X to the 0, because x to the 0 is always going to be 1. And when you times a 0 by something, you get nothing. So that's the reason why. But you don't need to know that. All you need to know is that constants like this get deleted from existence. Now we have the derivative. What on earth are we going to do with it? Well, we're going to say what we're going to do. Because we want this to be 0. Because remember, derivatives calculate gradients. So I'm just going to say what I'm going to do. I'm going to say, that's not how you spell it, but for SPs, SP stands for stationary point. Comma, gotta have good grammar. dy dx, I swear that's a d, equals 0. This will get you another mark. So then we can just throw 0 into our equation. And then we can start breaking it to bits and making it, solving it. So this is a cubic equation, but so it does look pretty daunting. But what you want to do is find the biggest common factor, the highest common factor. And a factor is just something that you times to something else to get something. So for example, a factor of 2, for instance, would be 2. 2 and 1 will get you 2. And those are the only 2 factors are 2. but we also want to include these x terms as well. We want to end up with the lowest number, because these cubic terms, they're really irritating and I don't really like them. So what are we going to do? Well, I'm looking at this and I'm thinking I can divide both sides already by 2. So let's just put that out here, right? But I want to get these x numbers as well. And hey, x to the squared goes into x to the cubed, because if I quickly draw this out over here, times x equals x to the cubed. So like, okay, well, we can divide everything by 2 to the x to the squared, right? Throw in a bracket, and all we need to do to get this is the top one from that is just x, right? After we divide it. And then we have minus 3, but the x squared terms cancel out. So we end up with this. Now, remember, when you have 0 equals something times something, one of these has to be 0. Could be either one, could be both, but one of these has to be 0. So either, split it down, you won't need to write these to get marks, but they're helpful just to get the idea in your head. Or, so 0 could equal 2x squared, or it could equal, if I actually know what I was doing, minus 3, and I'll give you 2 different answers. This one is easy because remember, x squared is just x times x, and it's all multiplication, so x has to be 0. This is a bit difficult, but basically, if you add 3 to both sides, this will become just x, and this will become 3. And I'll shift it around just to make sense. And there you go. And if we look at this over here, it's just x coordinates. They don't want to do anything fancy. So there you go. You're solid. Because sometimes they want you to put it back in the original equation and find the y coordinates, but you've been saved here, you don't need to. So moving on. Question number 2. The equation x squared plus k minus 5x plus 1 equals 0 has equal roots. Determine the possible values of k. Okay, well, yeah, this seems as difficult as well. But remember, equal roots. This should immediately trigger something. It's called the discriminant, which it's not acting bigoted, unfortunately. It's if you remember back to N5, there was a called quadratic formula that no one remembered. It was this horrific mess, but shouldn't really need that too much in higher. But I'll write out the whole thing. Just might as well flex my muscles. This symbol here I'm drawing means plus or minus because you get 2 solutions, like with quadratic things. Ooh. Yeah, luckily you shouldn't really need to do this much in higher anymore, which is a godsend. But so what we can look at this is inside the square root. This will tell us how many roots there are. And how do we know this? Well, if this bit was 0, right? Then square root of 0, still 0, so plus or minus 0, so there will only be one solution. So the roots would be equal. And then if there's more, then there would be plus or minus something, so it would be more. And then if there was negative number, oh boy, you get into weird territory, and there's no real roots. But we don't need to worry about that now because it's only equal roots. So you don't even need to write this. This is just for fun. But basically, you take the discriminant, and you go. I always go when b squared minus 4ac equals 0. You can say equal roots or something, just to tell a marker what you're on about. They'll try their best, but give them a helping hand every once in a while. There we go. Okay, well now all we need to do is substitute them in, because remember, this equation here is based off the standard quadratic equation, which looks like this. Probably need to do a bit more color coding here, but whatever. All right, so now we can just look at this and compare it to that. So here, A, well, that's 1, because there's nothing to, it's just x squared. And here, B, that must be k minus 5. Finally, last but not least, C, that's just 1. Coolio. So we can throw this into this equation. So b squared, that would be k minus 5 squared, and put brackets around that. I'll fix that. There we go, that's way better. Time minus 4, and then brackets just to make things quite clear, but A and C are the same, so it's actually really simple. This is actually quite a nice one equation. And can I extend out this canvas a bit? I've made it really long, but maybe not quite so much wide. That's more like it. So this equals 0, because we wanted to have equal roots. So then we can just start multiplying things out. So times in brackets, remember k minus 5 is the same. I'll just make this really simple. You can get good at these and just kind of do them in your head, but it helps when you just not make mistakes while writing it out on paper or computer screen or whatever you do. Cool beans. Right, well, let's do first and first. K times k. What is that? Well, that's k squared. And then minus 5 times k. That's minus 5k, just as it says on the tin. And then you do it again, because you basically go over to this side and you go minus 5k. And then minus 5 times minus 5, minus times minus, that's a positive. So you get plus 25. And then you know what 1 times 4 is, right? So it's just that. Those two just do nothing to 4. Cool. Now we can gather like terms, which basically means shove everything together. There's no other k squared terms, so that's fine. Minus 5 times minus 5, minus 5, ooh, that's minus 10k. Plus 25 minus 4, that sounds like plus 21 to me. Alright, cool. And this looks like a quadratic formula to me. So we can split this up. Now what you want to do here is when you split things up, you want to find a number. I'll see if I can move to red. That timeses, that timeses to get this number over here, and adds to get this number over here. So I'm afraid you're gonna have to just, there's no amazing way to do this. You can use the quadratic formula, but that's an absolute mess, as you can see. Best way to do it is you just take this and you're gonna make, I don't know what this is exactly called. I think it's a factor tree, where factors come in pairs usually. Less the number square. So you start at 1, and 1 times 21, that's 21. 2 does go into 21, it's an odd number, but 3 does, 3 goes to 7. And I don't think there's any other ones off the top of my head, because 4 doesn't go into it, 5 doesn't go into it, 6 doesn't go into it, but 7 does, and you're back here. So that makes it simple. 1 plus 21, that does not equal 10, but 3 plus 7, that does. Right, we have our factors. Ugh, so we can shove these in. Now, we need to remember, it's not just 10, it's minus 10. But when you multiply two minuses, you get a positive, so plus 21. So it's minus 3. And then k minus 7. Ain't that beautiful? So then we can just steal this and just go k equals 3. Because remember, this is equals 0. And when it has something equal, either this is 0 or this is 0. I'm just simplifying it because I already showed you up there. But k equals 3, because if you put 3 in there, that would equal 0. And on the same vein, k equals 7. Because you threw 7 in there, that will equal 0. And that should be your answer. Number 3. Circle C1 as equation x squared plus y squared minus x 2y minus 2y, I mean minus 26 equals 0. Circle C2 center 4 minus 2. The radius of C2 is equal to the radius of C1. Find the equation of C2. Okay, well, this does look daunting. Circles are always a bit of a pain in the posterior, don't you worry. But what we can do, so radius is equal to C1. So if we calculate the radius of this, and then we already have the center, so we can just shove it in the circle formula, which I'll show you later. But how do we calculate the circle of this? Well, it's kind of simple. You just go, there is in fact, in your formula sheet, you'll find this doodad here. So this will tell you exactly where to go. So you see 2gx, see 2y, and then you can shove them in there. So if we look at this, we can find that we need to divide both of these by 2. So we end up with -3. And you don't even really need to do the minuses, because when you square things, they get cancelled out anyway. But I'll just do them for clarity's sake. There's my watch going off. And minus C. So this number is C, but remember, it's -26. And because when you minus a minus, you get a positive, it's actually plus 26. So we can start multiplying this out. I'm really sorry for this dodgy handwriting. Use your imagination. Pretend I actually know what I'm up to. But that's 9 plus 4 plus 26. I swear that's a 9, not a 4. Okay. And that gets us everyone's favorite number, root 39. Woohoo. Yeah, right, don't worry, I did actually forget to... Remember, folks, you got to divide all numbers by 2, not just 1. So that's actually 1 squared, so that would just be 1. Right, mistakes averted. Everyone, 9 plus 1 plus 26. What do you think that is? Yeah, it's 36. Not any... Crazy to think otherwise. Oh, I don't know how you did that. But what's root 36? Well, we actually don't... We probably won't need to do it for this calculation, but it makes it simpler if we just go 6, right? So then, you can do all loads of calculations and put it into this formula. Don't. It's just a waste of time. Instead, we're going to go and put it into this because it's really nice and simple. So, the center, by the way, should probably put equals. It's not equals. It's a bloody center, you moron. Yeah, sorry, it's been a long day. Is this right? So, x minus 4 all squared plus, because I'm just using this formula here, a and b correspond to the center, as you can see here, but you just minus them. And then y minus a minus, that's a positive, so plus 2. And then it equals radius squared. We've already figured out the radius is 6. So that means it must be 36. And boom. Yeah, it's only 2 marks, you won't need to do much. Question 3, done, dusted. And maybe you want to put like C2 just to make it clear that's what you're on about, but they should figure that out, right? A sequence is generated by the recurrence relation, n plus 1 equals m, u, n plus c, where the first 3 terms of the sequence are 6, 9, and 11. Okay, well, what does this mean? So, un plus 1 is the next term in the sequence, and un is the first term, is the term you're currently working with. So, what I'll do here is make things simpler. I'm going to plug the numbers in. This will hopefully get you an idea what I'm on about, because I can go a bit insane sometimes. So let's work with 6. So 6 will be the current term, right? So that means we'll have m6. I know that's not probably how you should write it, but whatever. And then, well, what's the next term? Well, what comes after 6? In this sequence, it's 9. And we want to do that for the other jump in the sequence as well, 9 to 11. And let's see if we can catch on to see what I'm up to. So 11 equals m9 plus c. And doesn't this look really familiar to something we did in N5? Perhaps in one of my very first videos where I did one thing and then gave up. Wow. Bit of a lazy bones, aren't I? That's right, folks. It's simultaneous equations. So, notice these c's, they're the same. They've got the same coefficient of 1. That means, I'll lay it out properly, because I probably get railed in the comments if this isn't properly done. You can take them away from each other. You can do some funny algebra and get them to like equate to each other. But for this specific purpose, it's very simple doing this way. And we can take these c's away. So, what does that do? Well, 11 minus 9, that's what? Nah, I'm kidding. It's 2. 9 minus 6, that's 3. So I'll keep the m's on this side just to irritate you. And a c minus a c, that's nothing. So 2 equals m3. And then we can just move the 3 onto the other side, i.e. divide both sides by 3, I suppose. So that'll be 2/3 equals m. Right, after that jump cut, I'm back. Oh, shut up, Windows Explorer. USB for that. Oh my Mars, right. You can't recognize my bloody phone. Okay, whatever. We figure out M, right? And we've got two equations to test our theory out on. So let's shove 2/3 into M on the, I don't know, we'll go bottom equation, this one. It'll make things, you want to go with the equation with the lowest numbers, it just makes things simpler. So since we know M is this, I'll put it in brackets just so we don't get too confused, plus C. So when you times in fractions, remember that, I'll go and put it in reds, you can imagine whole numbers just like that, and then you can times the top by the top and bottom by the bottom, or numerator by the denominator if you're fancy pantsy. So yeah, I'll do it nice and slow. 6 times 2, that's nice, that's 12. And it's over 3, because 3 times 1 equals 3. And then we can sort that out because 12 divided by 3, well, everyone knows that. That should be 4. And then what do you add to 4 to get 9? Well, you add 5. So C must equal 5. If you're feeling cool, you could actually move the 4 over to that side and take away, but you can just go from there. So it's equal 5. And then that's, you've actually answered the question, M and C. Now, what I always recommend with doing simultaneous equations is you go to the other one, and you don't even need to write this down. Just have a look at it and make sure that what numbers you've got makes sense. So 2/3 times 11. Let's have a gander at that. Well, 2/3 and put this into the 11 equation, I guess. Again, yeah, you don't need to do this, but I would always recommend it just for good thing. Does this work? Well, 2/3 times 3, so remember, you can pretend that 9 has got a 1 underneath, and then, so that's 18 divided by 3, which is 6. I hope I'm getting you there, but you can also think you divide 9 by 3 and times it by 2, which is 6, right? And then 6 plus 5, oh my gosh, it's 11. So yeah, guaranteed we've got the correct ones, and yeah, looking at the marking scheme, we have. So yeah, that's 3 easy marks right there. I have realised there is an A in the B part, so yeah, I don't know, poorly drawn out A, and I'm going to have to extend the paint canvas again. Right, on to B. It's only a 1 marker, so we'll get this done and dusted. So heads calculate the fourth term sequence. Well, we've worked out the equation. In fact, I can tell you to. The next term in the sequence equals 2/3 times the current term in the sequence plus 5. And then the 11th is the first term, so we want to figure out the fourth term. We can shove in 11. This will get you, I'm already looking at it, this will get you a really irritating answer. The SQA sometimes has really neat stuff, and sometimes they just give you horrific things for no reason. But yeah, remember 11, it's like 11 over 1 essentially. So that means we can just go 22 over 3. How do we add 5 to it though? Well, remember, it's 5 technically over 1. And I hope you remember how to add different fractions. What you do is you're like, okay, well, I can get from 1 to 3 by timesing everything by 3. So I'm going to have to go out. I'll have to switch up a bit. So we're going to times everything by 3. There we go. Now we can add them because they have to be the same denominator or bottom number. And what's 15 plus 22? Yeah, it's 37. What? Over 3. And you could put this out into 12 and 1/3, but I am a big proponent of your so-called improper fractions, where you have like larger number on top than you do on the bottom. So I'll leave it at that. And yeah, it's perfectly legible. It's fine. So yeah, there you go. That's the first 4 questions. I'm going to have to create a new thing. A new amazing thing. Are we ready, folks? You better be. Okay, after that brief jump cut again, I needed to make a new canvas, unfortunately. Let's move on. Question 5. Yeah, it's going to be a long haul, I'm afraid. There's like 17, there's literally 17 questions in this past paper. They're really torturing us. Show the points of the points A, B, and C are collinear. Now, collinear is a stupid fancy maths way of saying in a straight line. As in, if I got a gun and shot a single bullet, the beam of them would pass through all of them in a nice straight line. So like, the Yeah, you get the picture, right? But yeah, collinear just means in the same line. So, how on earth do we do that? Well, what we can do is, can I make a, right, so hey, I've got a point there, I've got a, oh, okay, these diagrams are not to be, like, I'm gonna say, I've got a point there, I've got a point there, I've got a point here, and I'll try not to expose my secrets to the world. Right, I'm gonna fire a beam right through them. So I only know that these are collinear, but how can I prove that? What am I doing? Yeah, that looks right. I should have used the shape tool, but shape tools for cowards. So that's A, that's B, that's C. Well, if I know that the gradient of this is the same as this, i.e. they're parallel, right? So if I can select this and go move it down here, it'll be the same as A to B. And since B is a common point, they must be in the straight line. All right. Okay. Well, if we know that, how we're going to calculate? We can't calculate gradient because it's a 3D plane. Oh, well, that's really irritating, isn't it? Well, don't worry, we've got a solution. Everyone's favourite topic, well, I mean, I quite liked it, probably no one else, is vectors. Yeah, like the guy from Despicable Me. So what you want to do is write down the vectors of A to B and B to C. So A to B, you've represented by doing this. That should be a arrow. It's not really an arrow, looks like a person swimming, I'm afraid. Um, and yeah, you just work out, I guess, the distance, supposedly. So 4 minus 1. What do you think that is, guys? It's 3. It's not 2, as I probably thought. Um, then you have minus 1, minus 5. Oh, that's minus 6. And then you have 0 minus minus 3. So that's a 3. Alright, that seems cool. Let's move on to BC. Let's see if we can notice anything particular about these two vectors. Because if this question is assigned correctly, which it should be, being from an actual past paper and all, it will tell you there will be something special. Let's see if you can spot it. Eh? So, B to C, you add 4, and then because you go from 4 to 8, then, yeah, that's another way you can figure out. You can take away, like you can go, 4 minus 1, or you can think about, oh, I need to get from 4 to 8. What do I do? So I'll do the second one that way. So I want to get from -1 to -9. How might I do that? I think I'm going to subtract 8. That seems like a solid bet. And then I want to get from 0 to 4. Well, I'm going to add 4. Notice anything particular? These two can be made multiples of each other because they've all got the same pattern, like this. If we have another vector, just point this out, that looks like this. AB, that equals 3 of that. BC equals 4 of that. And if vectors are multiples of each other, then they're parallel. Okay, so how can we show that? Well, there's a few different ways, but basically, the one that I've got looking at the marking scheme at the moment is we want to say that we want to connect these two directly. So AB, and we want to figure out how can we get it to equal BC? Well, we've already established that AB is 3 of that and BC is 4 of that. So, how do you want to convert the two? Well, what if we divide by 4 first, right? And I'll put BC here, because that'll get us from, not another swimming person, that'll get us to that, right? And then we times it by 3. Boom. So this proves that they're parallel. And then I'm going to pull up the text tool here. How big is my, oh mine, they can make it really small. Free my text, man. Yeah, that's a bit better. We basically need to write a ton of stuff. So, AB, oh right. I love text boxes in Microsoft Paint. AB is parallel, if I could good enough. I kid. Ah, you spell parallel. Oh, there's another. Oh. Right. Sorted. 2 BC. Um, B is a common point. Make sure to mention that. If you want to be lazy and don't like too many words, you can say is parallel to. You can actually rewrite that as write down both vectors. I write down this like kind of sideways equal sign. That means it parallel to. Hopefully your lines are straighter than mine. And then you go and conclude from that. Oh my, why do they make me do this? Poor letters, mate. Like you can barely see them. I'm typing in the wrong bit, am I? There we go. Points A, B. I use the octave comma. Why not? C are colini in a slightly annoying text box. Yeah, mate. I want to type down. Genius. And there you go. 5A. That's only 3 marks. You've hit all the points. And state the ratio in which B divides AC. So, well, what does this mean? If we go back to my amazing diagram here, basically what it's saying is what position is B in. If it was splack back in the middle, it would be 1, 2, 1, right? Because that length, this length here will be the same length as there, right? But if it was, say, 2/3, it was only 1/3 along here and then 2/3 like that way, then it would be 1, 2, 2. You see, because that length would be twice as long as that. Maybe drawing it would help a bit. Maybe not in my case. Yeah, imagine this length is 2 times as long as that. Then it would be 1, 2. So we just need to figure this out for our weird line here. So you could draw it out, like they do provide all the points, but that's a lot of time and effort, and I personally hate drawing with a burning passion, so I would never do that. So what you do, remember how we made this earlier? Well, we can kind of reuse this. So these, we consider these like be the unit. So the whole way through is 7. Right, and you can go back, you can calculate the length from A to C. Whole way through is 7 of these repeating units. And this is state issue, so you don't even need to do any working. You can, if you just have like a divine inspiration, you can just write that down, and you'll still get the mark. So the way I'll do it, we've already got these. These say it's 7. So that means our total thing should add up to 7 because we've got 7 of these like individual blocks, if you will. But you can see here we've already established that this goes 3 and then it goes 4. So that means it just must be 3, 4. There you go. There's other ways to do it. You can just like divide through and calculate, but there you go. There's your answer. That's the way I would pull it off. Number 6. Given that y equals that horrible thing, find dy x. Sometimes they'll put stuff like this, like x does not equal 1/3. Now, you may be confused about that, about what that does. Don't worry. When they have a non-equals thing like this, it's usually to stop this from being a weird undefined equation. So if I put 1/3 in there, right, then that would become 1. It would be 1 minus 1. Whatever, 0 to, that's 0. If you just times 0 by itself 5 times, it's still 0. So it'll be 1 over 0, which is not a number, it's undefined, so they explicitly exclude that, so you don't flip up. So yeah, don't worry about that. There are some equations that you will need to have a look at these when they have like limits on it, but usually 99% of the time, don't worry. But yeah, let's go and write out our equation, eh? because we will need to do a bit more nonsense than the previous one. Cool. Can we take the derivative right now? No. We've got this bloody one that's ruining everything. But don't worry. See, law of indices, they call it. If I've got a number like this, I can actually just represent that as x to the minus of whatever that was, okay? So that means we can just go and rearrange this equation as this. Cool. And now we've got something to a power, and it's all good. We can divide it. There will be something slightly wild about this because we're going to have to use the chain rule. Oh, that's not good, guys. Don't worry. So, well, let's start, eh? So, again, as per usual, minus 5. And I'll leave a suspicious gap here for later. And minus 1 for power. So we go down to minus 6. What do we put in the suspicious gap? Well, chain rule, stuff in the brackets. If it's a linear equation, which basically means if I had y equals 1 minus x, it would make a straight line, right? If there's like any powers on here, the chain rule doesn't work, but they won't punish you with that, the SQA. But double check it just in case. They might be trying to pull a fast one on you. So what you want to do is take the derivative of what's inside here. So remember, when you take the derivative stuff, constants disappear. You want it to disappear with that. So you're just left with minus 3x. And what's the derivative of minus 3x? Well, x goes down to 0, so it becomes 1. So it's just minus 3. That looks good to me. And what's a minus times a minus? Well, folks, it's a plus. So it's the same as positive 5 times positive 3. So it's 15 times whatever this horrible thing is. Alright folks, we're back. I had to double check this, and like the market scheme is like completely insane for no reason, but this is the answer. I'm like 99% sure. Don't know what's going on there. But yeah, we'll just move past that slightly irritating thing on to the next question. 7. The line L makes an angle of 30 degrees with the positive direction of the x-axis. Find the equation of the line perpendicular to L passing through this coordinate 0, 4. 4 marks, so slightly harder than usual. Well, what on earth does this word jargon mean? Because it seems pretty darn silly. And yeah, they can definitely well scare it. But what's always good, let's draw a wee diagram. Yeah, whatever. There's my brush. Maybe I'll turn the thickness a bit so you guys can see it better. Question 7. Positive direction of the x-axis. So what we're going to do is we're going to draw a graph like this. And positive direction, that's just this right there, right? So that's the positive direction of the x-axis. And now 30 degrees, all that really means is, well, let's see, I can do a nice straight line. No, I can't. There you go. I'll go and I'll make a slightly better one. Eh? All that means is that line here is just not to scale at all, but that angle there will be 30 degrees. Okay, well, how on earth do we figure that out? Well, don't worry, folks. It's actually surprisingly simple. We use the formula m. Remember, m equals gradient because why not? They have lots of weird things in there, certainly. Is tan theta. Theta is the angle we're looking at. It's just a nice little Greek symbol because the line making things are wee confusing. So we just need to figure out what is tan of 30 degrees. And to do that, we can use our exact value triangles. So I'll recommend actually drawing these, like in this section up here. You won't get them. Draw like a wee doodle of your exact value triangles because they do come in quite handy. But for this, I'll just staple them on right here. And of course, they'll look absolutely. Oh, I'll make them way bigger. Yeah, let's go bigger, go home, and I'll do it in blue, so no one else. You will always know because I might come back to that. So yeah, that's how triangles. You've got 2 on that side, root 3 and 1. And then this angle here, that's 30 degrees. Well, 60 if it's 60, sorry. And then this angle here is 30 degrees. And then, just to save time later, I'll do the other one, make sure. Because you never know, you may need it. And another one is way simpler to remember, because it has a lot less stuff going on. It's just root 2 over here. Sorry for the wind, folks. I live in a very windy place, but I hope you can't hear it that well. And then it's just 45. That is not a 4. As you can see, it's an anti-4. It's 45 there, and there's 45. I keep making the same mistake. Oh, hopefully that wasn't my house falling apart. Alright, so yeah, you'll need to remember these. Hold on, just remember all triangles when you add up their angles together at 180. You can't remember one or two, you can just work it out by calculation. But look at this, 30 degrees. And we've got 30 degrees right in there. So think back to N5 to trigonometry. You'll know that tan equals, I'm going to write it up here in fact. Tan equals opposite over adjacent. And we're working out 30 degrees. So opposite, that'll be 1. So I'll go and write that down. Cool, cool. And then adjacent, that'll be that. So it'll be 1 over root 3. So we'll figure out the gradient, but where that's only half the battle, we need to get the whole we need to get not just the equation of L, but the equation of L perpendicular to L. So how on earth do we do that? Well, there's another bloody formula you got to remember, because they don't tell you these, unfortunately. But basically, M perpendicular, this we sign means perpendicular, equals M, hang on, we'll just go back a bit. If you times M by its perpendicular, you'll get minus 1. Okay? So, I mean, yeah, this does make sense, right? Because if I have a line that's just going up by 1, the one that's perpendicular will be going down by minus 1. So forth. And this may look some people may struggle with this, but a simple way to do this is because you may look at this and go like, oh my mod, what am I supposed to times this number by? 1 over root 3 to get minus 1. Well, it's surprisingly simple. You just flip the fraction upside down and change the sign, right? So you end up with this, what we call root 3, 1, and it'll be minus equals m. And you may be asking, well, how does that equal minus 1? Well, remember, when we times fractions together, root 3, well, minus root 3 in this case, that'll go there, and 1 times root 3, that will change. And then when you divide, you have two numbers that are the same on a fraction, you divide them, and you get minus 1, because it's a minus. So yeah, it does make sense. So that's our line perpendicular to it. Gradient. But that's not the whole thing. We've got to figure out the y-intercept. But luckily, it actually tells us right here. It is minus 4. So we could actually just jump straight to it. But for clarity's sake, I'm going to do the old-fashioned equation. Just to be exactly sure. Because yeah, this is actually the y-intercept. We don't actually need to do any weird messing around with this. But let's just, do it a nice and slow way, because it's good practice to use this equation anyway, because it's helpful for more complicated problems, I mean. And remember, when you have a number that's over 1, you can just kind of get rid of it. It's not mathematically incorrect, but get it simplified later, because you don't need that minus 1. So let's throw in our numbers. What's b? Well, it's minus 4, but we're minusing a minus, so you know what that means? It's a plus. Cool, cool. And then m, well, we know what m now is. It's minus root 3. And then we have x minus a. What's minus a? It's 0. So we can actually just kind of ignore that whole bit. That's very helpful, don't you think? So y plus 4 equals minus root 3 x. Make sure to draw your x outside the square root, otherwise stuff could go down. And then what we need to do here, we need to move that 4 on the other side. So take 4 away from both sides. We'll end up with y badly drawn as per usual. Hope you've gotten used to this by now. Oh, that is a poor X even for me. Let's go. Let's do it a bit closer. Yeah, there we go. That's beautiful. Boom. Ain't that beautiful? And that is your equation. Ah, psych! I did just a mistake. I pointed out myself. You need to draw X on the outside. Goody gosh, I'm sorry you guys have to get put through this. But yeah, there's your equation. Try and write it better than I can, but it is the correct answer, so can't be all wrong. Next on, we're moving on to A. It's integrals. 8A. I love some integrals. So, first one, it's a one marker. Oh my god, that's going to be lovely. So, graphs of y equals x squared plus 2x plus 3 and y equals 2x squared plus x plus 1 are shown below. Okay. They intersect at x equals -1 and x equals 2. Cool, cool. And we want to find the shaded area enclosed within the curves as an integral. So yeah, this may look confusing, but don't worry, it's actually simpler than you think. So I'm going to go say shaded area. I'm going to abbreviate it as SA, and I want to make it into a grid tool, and then it should only take up one line. So remember when you're doing an integral of a specific shaded area, the limits of that integral will be the points that you're calculating the shading area over. It won't be an indefinite integral, it will be a definite integral. So, well, I mean, we could just stop putting in. Lower one is -2, high one is 2. So, I'm going to write that in there. So that's part of our solution. But now you'd be like, oh my god, but MASH, it's not on the x-axis. It's these two things. What am I supposed to do? Well, what we do is it's upper minus lower. So I'll actually write that up here. It's always upper minus lower. And the way you define them, you just see what is on top most of the time, and kind of cross your fingers, to be honest. So you see what equation is upper. Now, what do you think upper will be in this one? Well, I think it looks like this because it's positioned there and it's always above this bottom equation. Okay, well, what we can do then is I'll do this over 2 lines just to be absolutely sure everyone's fine with this. We'll throw this in here, upper minus lower. Oh dear, this is going to ruin my mouse sound, isn't it? Plus 3. I'll put it in brackets, minus, and then how much can I move over here? Oh, not a lot. Hold on, we'll just do a wee bit of engineering. Yeah, there we go. That's going to make my computer run fine and it won't explode. Oh dear. Okay, well, I'll make a new thing at some point. Put the other one in here if I wasn't drawing in white. So it'll be 2x squared plus x plus 1. Now, you can actually go from here and integrate it, but honestly, that seems like a real waste of time. Let's go and combine these equations so we don't have to do as much work in the future. So, oh dear. What is x squared minus 2x squared? Well, they're both like terms, so we can actually just use them. So it will be minus x squared, right? Because 1 minus 2 is minus 1. Then 2x minus x, that's just x. And then 3 minus 1, oh my god, no way, that's 2. And that's actually all we need to do for A. We just need to express it as an integral. And then we're sorted. But, do you realise what I've forgotten? That's right, I'm going to put it in bright yellow so everyone knows you have to write dx, which basically means you're integrating with respect to x. You've no idea how many bloody marks I've lost because there's 2 letters, okay? Please, for the love of all that is holy and good in the world, write your dx's, okay? But yeah, as long as you remember to do that, you'll be fine for A. You'll get that single mark, 1 juicy mark. Well, let's move on to B. We'll try our best. So, we've already got an integral. We just need to evaluate it. We just need to figure out what this is. So I usually write the integral, but it's literally right there. So I think we should just get straight into it. So first thing we want to do is we want to make sure it's actually ready to be integrated. And it looks to be fine. Everything's in power form. There's no weird nonsense. There's nothing we need to convert into anything. So I think let's just get integrating. So I'm going to put these in here because we need to sort out these limits a bit later. Okay, square brackets. Now, when you integrate something, what you're going to do is it's the opposite of taking the derivative. So we're going to add 1 to the power, and then we're going to multiply. We're going to divide, sorry, by the new power. So in this case, we'll divide by 3. Okay, and what does that get us? That gets us minus x to the cube over 3. Fantastic. Move on to this. Now, when it's a single x term, you can do it. It will go up to just plain, it'll go up to x squared over 2. Because 1 plus 1 is 2. You divide that by 2. And then constants still disappear. They turn into actual x terms now. And there you go. Because remember, that's 2. It's technically, you can think of it as I'll zoom in a bit here. Yeah, there we go. Great handwriting. Oh, fudge. Let's use the pencil. That 2 is technically timing by an x0 term. And when you add 1, you get up to x1. But of course, divided by 1 does absolutely nothing. But anyway, so now that we've got this beauty equation sorted, we need to throw in our limits. 2 and minus 1 at the side. And then now the annoying bit. We're going to have to plug in these into our equation and do nonsense with them. So, start with the top term. So it'll be minus 2 cubed over 3 plus 2 squared over 2 plus 2 times 2. And that's that done. And then we need to do minus 1. So minus 1. And we'll put this in brackets because when you're doing powers of minus 1, it's helpful. Because otherwise it might be minus power rather than a power of a minus if you get no catching. So just remember put it in brackets. It makes it, especially when you're putting in calculator, it makes it far easier to not flip up. And then same here, put that in nice wee brackets. Divide that by 2. And then plus 2 and one final bracket. And there we go. And now we have to compute this, which is the boring and annoying bit. So I don't have a lot of room left, but I bet I can pull out a bit more white space, even if it would be the death of me. There we go. Computer's good. You can hear the fans going. Microsoft Paint maybe not be entirely well optimized, ain't it? So I'll try and do this slowly because I know it's a lot of terms to get used to. So let's just do all the powers at the start, eh? So 2 to the power of 3, that's 2 times 2 times 2, so that's 8. 8 over 3, not a nice fraction, but well, we get what we get. And now 2 to the power of 2, that's 4. Now that's a way better fraction. We can simplify that to 2, but for now, I'll draw an actual 4 that everyone can understand. That's cool. We can simplify it to 2 later. And in a similar vein, 2 times 2, well, that's going to be 4, isn't it? Boom. So that's looking more like it. Then over here, then we have to deal with minuses. Now, minus powers can be kind of annoying sometimes, to be fair. So, minus 1 times minus 1 times minus 1 is minus 1. Yeah, it's entirely useless. So remember when they're odd powers, there'll be minuses. And if they're even, there would be positives when you're doing powers of minuses. So yeah, these would actually cancel out. So it would actually be plus a third, but we'll keep it as is for now. And then it's even, so it would actually go, it would be minus 1 times minus 1, which is just 1, positive 1. And then 2 times minus 1, well, that's just minus 2, isn't it? Okay, that's looking a bit better now, isn't it? So what we could do is yeah, actually, let's do that. We're going to go term by term because I've realized these fractions are all nice and the same, right? So that gets turned into a positive. But as it gets turned back into a minus, where all these there's too many minuses, mate. But basically, you're minusing a third from that side. So that means you go up to minus 9 over 3. That looks easy to simplify. And then we're minusing a positive 2. So that would be plus 3 over 2. Because we're taking a 1 away from 4 effectively. And then we're minusing a minus, so we actually go up to 6. Good golly, I'm sorry, folks. But then we just need to sort this out. So, obviously, 9 divided by 3, that's just 3. And then 3 divided by 2, we can't really sort that out, so we'll just express it as that for now. And then plus 6. 6 plus minus 3, well, that's just 3, isn't it? So it'll be 3 plus 3 over 2. And that's effectively 3, if you want to think about decimal, it's 3 plus 1.5. So we could write it as 4.5, but the SQA do love their fractions. So I'll go and convert this into we convert 3 into a fraction. We'll times that by 2 because we want to get it to the 2 term. So it'll be 6 plus 3. So eventually we'll get 9 over 2. And there's one final thing we need to do. I mean, I don't think we need to do this, but shaded area. We don't know the units, but I would always write units squared just to make sure. So that's your shaded area. You can even write out saying shaded area equals 9 divided by 2. So there's integration. Hope it wasn't as difficult as maybe you previously thought. We're moving on to vectors yet. But firstly, I'm just going to have to create a new paint file. So, question 9. That's grade 9. We've got loads of bits to this question, and it's everyone's favorite subject, vectors. I don't like this. We'll go back to pickles. So vectors u and v have components p minus 2, 4, 2p plus 60 minus 3, 6, are pure real numbers. Final equation for u dot v. Well, that's the dot product, all right? And, well, what is the dot product? Well, luckily, I believe this is one of the equations you do actually get. It's this right here, and this is for calculating angles, but we don't need to do that for this equation. So you could throw that in there if you really want, but if we look down here, actually, it's only a mark, so we kind of expected to just know this, and let's face it, it's not too hard. We just times each of these terms together, so it'll be p times 2p plus 16 minus 2 times minus 3 and 4 times minus 6. So yeah, let's just go and get cracking with that, eh? So p times I need to write 2 there, don't I? Plus 16, and then that's plus minus 2 times minus 3. Cool. And then it's just plus 4 times 6. So I probably don't need to do brackets for that, do I? So yeah, there you go. If I can write 6. Oh my god. Yeah, that's a 6. Well, this looks pretty simple. So what's p times 2p? That's right, folks. It's p squared. What's p times 16? That's right, folks. That's 16p. And then what's minus 2 times minus 3? Minus minus, that's a positive, so that's plus 6. Positive 6. And then plus 4 times 6, that's 24. This is looking like a quadratic, but let's just simplify it. 6 plus 24, that's 30. Yeah, so this is called collecting like terms. And there we are. A nice wee quadratic equation. And yeah, we just need to find an expression. We don't need to do anything on it, which is why it's only 1 mark. So we can actually move on to the second bit. Cool. Determine the values of p for which u and v are perpendicular. Huh. How can we do this? Well, thing about the dot product is that if the vectors are perpendicular, the dot product will equal 0. Okay? And what the expression is for UV, I probably should have actually written this down, but oh no, it's U dot V equals this. So we actually have already figured out the dot product. So that means, I guess you could say, when U and oops, V are perpendicular. I'm really regretting not using the text thing. You know what? I think I will. Cut this out, Madison. Alright, I tried to do it in handwriting. Didn't really work out, honestly, so yeah, with this. Please let me type in the thing. There we go. So you can just say, when U and V are, extend this out way over here. Yeah, everyone's favorite Microsoft Paint, ain't it? Perpendicular. Thanks for autocorrect. You can say that U dot V equals 0. So this just tells the marker you have some idea of what you're doing. So we can just slot 0 right into this equation we've put up here. 0 equals 2p squared plus 16p plus 30. And then we just need to solve a quadratic. Okay, so I'm looking at these. All of these are even numbers, so I'm going to make it as easy for myself. Because remember, top maths rule, never do more work than you have to. Okay, so I'm going to divide everything by 2. That is that's a non-straight line. All right, because it just means the numbers are smaller, so they're easy to digest. So 16 divided by 2, that's 8. 30 divided by 2, that's 15. So what can we do from here? Well, we need to find two numbers that add to get 8 and multiply to get 15. And again, you could do fraction trees, but I take factor trees like I saw you, but 15 I know only has 4 factors, 1, 15, and 3 and 5. And yeah, 3 and 5, those add together to get 8. So those sound like a winning combination. So yeah, I think we'll just shove them in. Remember, folks, if I'm speaking too slow for you, you can always speed it up going to playback speed. So if you just want to see me zoom through this, that's all right. I won't take it. I won't be offended. So there you go. So now we just need to determine the values of p for a perpendicular. So remember, 0 equals two things timed together, and so one of these, either one needs to be 0. So p could equal minus 5, because minus 5, you put minus 5 in there, plus 5, that's 0. Or p could also equal minus 3, because if you put minus 3 in here, then those two will cancel out. And then you're sorted. That's all you need to do. Pretty simple, eh? And then B determines the value of P for which U and V are parallel. This is a bit more annoying if you ask me. I always just do something, honestly. But all right, so now we're doing B. I think it's a bit more bloody annoying, to be honest. I don't, honestly, it's a bit annoying to explain how to do it. But essentially you need to find ways to link U and V to see how they can make them factors of each other. So what you can do here is you can be like, it's like fractions, you want to get both of these numbers to be the same. And, well, look, it's minus 2 and minus 3. So if I times U by 3 and I times V by 2, well, that'll get me my these numbers to be the same. So let's go and try that. So we'll say 3U equals 2V. Sounds good. Now let's plug in our numbers. Because remember, when U and V are parallel, they'll be some way linked multiplicatively. They'll be made out of the same building block as I described up there, but this is a slightly easier way of doing it. It aligns more with the SQA's marking scheme. Yeah, I'm sorry, I'm not amazing at vectors, but hey, hopefully you do better at this than me. Cool. So, done there. Let's just multiply everything out then. So 3p, and then minus 6, and then 12. And you notice on here, we'll have the same numbers at the bottom, which means these two would be parallel. So then we'll just have to figure out algebraically what what p is. Because it just says value, so there'll just be one value. You won't need to calculate any weird ones. There we go. Those are looking pretty identical to me. And I'll make sure to put some nice brackets around that. Okay, so yeah, these two vectors should be the same. So 3p needs to equal 4p plus 32. Okay, well that looks a bit weird, doesn't it? So what we can do here, I suppose, is we'll just take away 4p from both sides. So that means, because 3 minus 4 equals minus p, so minus 3p equals 32. And then times both sides by minus 1, that must mean that p itself equals minus 32. There you go. And you can always plug it back into your original equation and see if it works out. So you could say, oh, it's minus 32 there. That'll be minus 48. Oh yeah, that would work. But yeah, it's minus 32. I know it's a bit disappointing answer, but sometimes in maths, it's not about the destination, it's about the journey. 10. Well, we're like halfway through. Oh, look, easy 2 marker. I guess 2 1 markers, which are probably even better, let's face it. So that means we can just write down stuff. We don't even need to do any workings whatsoever. That's fantastic, ain't it? So this diagram shows the graph of equations of y equals some function and y equals that same function times by a constant plus a. So this curving up equation is our original function. It goes through the origin and it has I believe that's a stationary point, a minimum at 2 minus 1. So we can already see that this new function has been flipped upside down. So this k would probably have to be negative. Well, yeah, it would be negative. But it wants us to do a first. So we'll just keep that in the back of our head so far. So it's going through the origin. So even if I have k is 100 bajillion, it's not going to go up, because 0 times anything, you're not going to get anywhere. So that means that a has to equal 3. And there we go. Through 1, 3 mark. Barely any work required. That's what I like to see. Now we need to find the value of k. So what I'll do here is you're going to have to put on your thinking caps and kind of imagine what this graph would look like if we took out a, because then it'll make it easy to calculate k. So if we subtract 3 from that, we get the origin, right? So that's looking good so far. And if we subtract 3 from this, we get 2, 2, right? And then we can kind of compare it. So I'll write this down actually. So 2, 2 we get from 2, 5, we're subtracting 3. So how do we get from 2 minus 1 to 2, 2? Well, we must be timesing minus 1 by a minus number. So if we times it by minus 1, we get minus 1. But it's, it's essentially, I guess, it's 2 divided by minus 1. What do we get? Well, we get minus 2. So because you times minus 2 by minus 1, you get 2. And then when you add 3, you get 2, 5. So that means k must equal minus 2. And that makes sense, because if you look at this, the new one function is far more exaggerated than the old one. But it's also been flipped upside down, so it has to be a minus number. And there you go. That's a whole question done. Not all questions in maths are horrible. This one certainly does look like it, though. Evaluate this horrific integral. Woohoo! Well, we'll go and write it down the start. It might help us clear our heads, eh? So, pi, if I can write pi, maybe I'll just draw like a American Pie at this point. But there you go. So there's our integral. Cos 3x. Oh no, it's got stuff in the brackets. We're going to have to employ everyone's least favourite mathematic operation, the chain rule. And don't actually think, please, for the love of God, don't forget the x's. You won't need to do it for this one, but just keep that in mind. Eh? Um, so, how do we integrate trigonometric stuff? Well, what we do is there's a sort of a cycle thing, right? So sine, I'll write this in green because this is something. It's good to have this somewhere in your booklet, eh? You draw maybe on the answer bit, but sine x. If I was to derive something, so these arrows going that way is derivatives. We'll get that to the equation later. I'll get cos x. I'll just double check that I'm not going insane. Yep. Now, what happens when I do cos x? Well, I'll get minus sine x. With me so far? And then if I was to derive sine minus sine x, I'll get minus cos x. And if I was to divide minus sine x, I would get positive sine x. So it gets this lovely little cycle. Remember, this is taking the derivative. It's not integrating, but integrating is just the opposite of taking the derivative. So we go backwards. So look, it's cos, so that means we're going backwards to sine x positive. That's fantastic. So let's start this whole integration, eh? So start with sine x. Now, unfortunately, we're going to have to do some chain rule shenanigans, but there's no coefficients, so we actually just need to do a bit of chain rule shenanigans, so it shouldn't actually be too horrific. So when you have the chain rule, you now look at the brackets and make sure the function's linear. But this, you take the derivative and you divide it by it instead of timing around when you do the chain rule and a derivative. You get what I mean? So it's a constant minus pi 6. It will just disappear, and then 3x now turn into 3. So that means that I'll just write this. Remember, when you're doing chain rule, you never touch what's in brackets of functions. They are untouchables, you know. Oh my mod. Oh, I'm so yeah. I'll fix that. That was actually terrible. I swear I know what I'm doing. I just have a bit of a shaky hand. Yeah, maybe I'll do it a bit more closer up so you folks can see it. Be divided by 3 because that's the derivative of this, and we're integrating. Sounds good so far. And remember, we're working in radians for this, and I'll put my limits on the outside. It's pi to the 9, isn't it? Fantastic. Okay, now we just need to do the annoying bracket bit, don't we? But that shouldn't be too hard, eh? Oh, so let's substitute in our limits. So that's sine, and that'll be 3 times pi over 9. Take away pi over 6. And now divide the whole thing by 3. There we go. So that's that limit done. And then we just do the same thing. We'll slot in 0 instead. Cool, cool. So another beautiful bracket. And divide it all by 3. Okay, there we go. So now we just need to compute this. So yeah, no easy way to do this, but let's do the stuff that's inside first. So let's calculate the whole thing here. But so 3 pi, because we're timing it by 3, over 9, right? I'm going to divide both sides by 3, because yeah, Whatever you do to the numerator, you have to do to the denominator, right? But then we want to subtract pi over 6. So I'm going to times this both by 2. That's supposed to be 6. Don't at me. Pi over 6. And what do you get? Well, you get a single pi over 6. Okay? So, yeah. Beautiful. That's sine of pi over 6 all divided by 3. Okay, that's that halfway computed. Now onto this mess. So, 3 times 0, you never guess, it's 0! So we're just left with this sign of minus pi over 6. So, yeah, should be pretty simple. That is a sign, I swear, it's an S. Boom! So now we need to pull out our old friend exact value triangles, which are not on this beautiful piece of paper. So, I mean, that's fine because the ones I did previously were the not exactly were the degree ones. We're working radians because we're cool like that. But I'll draw them in here. We only need to use this one. So zoom in a wee bit and start drawing these angles. Oh god, that's awful. Change the size down to 3 just to make it slightly more palatable. That's beautiful. If you have bad taste in art. So that's pi over 6. And this is pi over 3. Because remember, pi in radians is 180. So you divide it by 3, that will give you 60. Divided by 6, you get 30. And that's 90 degrees, so that's actually pi over 2. But we don't usually use that side. And we will be using it for this. And then just draw in your distances. That's not a root, that's a 2. This side is a root, that's root 3. And this side is 1. Cool, cool. Right, well, this is a negative one, will be a bit more annoying, I'm afraid. Yeah, I know, maths can be kind of a piece of work sometimes. I get that. So, well, what's sine of pi over 6? Remember, trigonometry, sine is opposite over hypotenuse. I'll just double check that that's, yeah, that sounds about right. So we're doing pi over 6. So this is our angle here. Opposite is 1 and hypotenuse is 2. So this will just equal, and I'll just double check that I'm not entirely going insane. That seems roughly right. That's half over 3. Now we can simplify that down because that's an actual pain. But a half over 3, that's, we will times these two together. So we would get pi over 6. Not just 6, just a 6 side. And then we need to work out what happens when it's minus. Yeah, so this will be fun. What we do here is we'll figure out the relative acute angle because we can't do that currently. And that would equal sine of pi over 6. Cool. We already know that. That is, it would be equal minus 1/2. Okay. Well, almost there. We're going to do the same trick we did there. So that would equal minus 1/6 because it's just the same thing but minus. And look at that. Minus and minus, you get a positive. So it's actually a 6 plus a 6. And that would equal 2 over 6, which means it's 1/3. And there we go. Oh boy, everyone loves their integrations. Okay, well, I'll have to make another bloody page, won't I? It's never, I feel like syphilis right now. But 12 looks easy enough. It's only 3 marks. So start with A. determine a function for this nested, this composite function we call it, which is where we get two functions, we slam them together. And they're defined by this: f equals 1 over root x, and g equals 5 minus x. So, these ones, the SQA are very particular about them for some reason. They really like you to lay them out this way. I'm going to write this, so this is what we're doing. And then we're going to slot in g of x in there. So it'll be f of 5 minus x. With me so far? Okay, and then we're going to slot it into fx. So this means that, I'll put some equal signs. It's 1 over, and I'll have to make some more white space, root 5 minus x. And there you go. That's it, actually. I'm not even joking. That's all you need to do. So maybe if you want, you can just be like, oh, just tie it back to the original equation just to make sure the marker, even if they're brain dead, they can understand what on earth is happening, right? But yeah, that's all you need to do. That's 2 marks. Welcome to the SQA, peeps. And then all we need to do is do B and state the range values of x for which this is undefined. Right. Well, I can already see here there's two actually things we want to avoid. So we do not want to have, I'll put this in red, we do not want to have any minus terms within the thing, because that creates imaginary numbers, and you just do not do that higher. I mean, it's complicated enough when you do them, but just don't worry about them now. They're not defined properly there. And also what you don't want to do is you don't want to have a 0 at the bottom of fraction, because that gets an undefined infinity and all that jazz. So we want to avoid negative numbers, and we want to avoid zeros. So looking at this, if x was 5, you take the square root of 0, which is fine, because 5 minus 5 is 0. That's the square root is fine, it's fine doing that, but you don't want 0 underneath a 1. Okay, so x has to be smaller than 5, because if it was any greater than 5, you end up with negative numbers, and that's even worse. So I'll just quickly do b, because there's only one marker in it. So that means if you want to be formal about it, you can write, oh, it's in you can't say, oh, it's excess of real numbers. I'll do it just to say I'm fancy. It's real numbers. So there's no weird ones. X is a real number. X has to be essentially, oh, excuse me, has to be greater or equal to 5. Because even though I've just said that we want to avoid these, but we actually want to see when they're undefined. So we want it's either of these situations. So if it equals 5, it'll cause this 1 over 0 problem. But if greater than 5, then it will go down to negative numbers and mess around there. But if it was looking for when it is defined, it will be the opposite. It should be x is less than 5, not equal. Righty, continue on forth. We're getting there, folks. It's a long road, but you've done really well. If you're following along at home, I'm just going to stop at paper 2 and release another video in a million years of me going over. I'll stop at paper 1. I'll go over paper 2 eventually, but I want to have lunch at some point. You know, I gotta edit it. But anyway, I'll start complaining about myself. 13. Triangles are both right angles, and angles P and Q are shown in the diagram. Okay, that looks okay. So I'm gonna go and copy these into. Oh, that's really small. Let's make it bigger. Yeah, beautiful. And then I think it's slightly squished. So you can draw these in the thing because it will, because it will actually make answering this a tad easier. Because if you notice, there's a few things that they've left out. Well, in this case, it's exactly one thing. We don't know what the length from A to C is. So, how can we calculate it? Well, it's basic Pythagoras. Everyone loves a wee bit of Pythagoras, don't they? So C squared equals A squared plus B squared, right? So we already know C squared, it's square root of root 5, so it's 5, right? Because you get cancel it out. A squared, it's 1. 1 times 1, that's 1. So what has to be b squared? Well, b squared would have to equal 4, right? So that means b must equal root 4, which, as we all know, is 2. So we can put 2 in here. We know the length of theta c is 2. But all the other ones we've worked out, so we're actually sort of start going on. So it says determine the value of cos p cos q. Determine the value. That's some golden words right there. No workings required. That's just fantastic. So cosine, that's adjacent over hypotenuse. So just go and write that in the corner here. Why not? This is from N5. Adjacent over hypotenuse. So caterpillar. This is cat. So adjacent over hypotenuse. And we're looking for cos p to start with. So look at p. Adjacent, we've just figured out, is 2. And the hypotenuse is the long one, so we root 5. So we can write it as this. And I'll even go to SQA. I'll tell them exactly what I'm calculating. But you can just write down 2 over root 5 and you get all your cool answers. Cool. That is a terrible P. Beautiful. And then we just do it for cos Q as well. So cos Q. Yeah, I'm doing it. I'll be standard. Yeah, consistent to me. Cos Q. Look at Q. Same thing. Adjacent over hypotenuse. Adjacent. Well, that's 2 plus 1. Oh, I don't know what that could be. Probably 3, right? And then hypotenuse is root 10. That equals cos Q. Ain't that beautiful? On to B. Determine the value, hence determine the value of sine P plus Q. What? This seems like it just comes out straight out of left field, doesn't it? Well, don't you worry, because I'll quickly write down what we're calculating, just because it does help you get in the headspace to do it, I think. There you go. So we want to calculate this. Well, how on earth are we going to do that? Well, whenever you're in luck, go to the formula sheet and it will tell you everything you need to know. So sine, right? If we expand this function out, equals sine A plus cos B plus or minus cos B. So we want it to be plus. So sine, in this case, it will still be plus. For cos, you'd reverse the sign because cos is a weird one, eh? But if we expand this out, that would be sine P. See where I got that from? And then it would be cos of the second. So cos Q. Coolio. And then plus, because sine doesn't change the sign. And then it would be cos A, or cos of the first, which would be cos P. And then it will be sine Q. That's fantastic, ain't it? So, what this has done here, we've already worked out half the equation, but now we need to do sine P. So, what on earth is sine P? So sine, it's so it's a opposite over hypotenuse, right? So, if we're looking at sine P to start out with, 1 is opposite and hypotenuse is root 5. So we can write that in. And then times cos Q, we've already worked out, it's 3 over root 10. So we're solid there. Fantastic. Cos P, what on earth is that? Oh, well, we've already done it. So we can just kind of copy and paste there. I do like these questions when they just kind of handhold you through it. It does make it a bit easier. So what on earth is sine Q? Well, look over here. Opposite over hypotenuse. It's 1. And it must be over root 10. Okay. Let's shove these things together, shall we? So, 1 times 3. I hope you know that. That is 3. 5 times root 10. That is root 50. Seems good enough. Then plus 2 times 1. That's 2. And then another root 5 times root 10. So that's 50. Brilliant. And then let's add them together. Same denominator. So we can just go straight to 5 over root 50. And that's a pretty bad answer, don't you think? How about we divide everything by 5? I want to divide everything by 5, but this root is really flipping everything up. So before we don't actually do what I want to do, I'm going to convert it. I'm going to use some surds. So 50, that's 2 times 25, right? I think I know where I'm going to go from here. And 25 is, if you square root it, so I'm going to convert this into 25 times root 2. That still equals to 50. You see where I'm going with this now? So that means that 5 equals 5 root 2. And then we can divide everything by 5. I can do what I always wanted to do. And get 1 over root 2. And that's your answer. Continue on forth. Oh yeah, baby, it's logs. Everyone has a wee bit of logs, don't they? So 14a. Oh. Evaluate log base 10 4 plus 2 log base 10 5. Let's write that out. I believe this one should be quite fun and easy. Yeah, I do. Some people do get a bit scared of logs, but there's only a couple rules you need to remember. So, first thing is, I don't write random stuff on the end of my log terms. I'm going to move this 2 and move it over here. How do I do that? I'm going to make it into a power. Okay? It's log base 10 4 plus log base 10 5 to the power of 2. And we've already done stuff like that, so that'd be 25, wouldn't it? Beautiful. Because that's, I'm just going to write that in red just to make sure everyone's up to speed on that. But it's because it's 5 squared, right? Cool, cool. Now, when you add logs, you just multiply them together. So what's 4 times 25? That's right, 100. And remember, you can only have logs with the same base, but they're both 10, so we're solid. That's great, ain't it? And 4 times 25, as we just established, is 100. Not 10. I don't know what I was on about there, but no. Log 10, base 10, 100. Now, here's the tricky bit. So, well, you can just look at that and see how many powers of 10 do you need to go to get 100. And I think it might be 2, right? Now, why is it 2? Because if I just go and write out my workings here, go do 10 to the power of 2, you get 100. See what I'm getting through there? So if you take log, because kind of log reverses this, it'll be 2 equals log base 10 of 100. Beautifully written out there. So it'll be 2. That's your final answer. Cool, cool. Right, we're almost there, folks. I know it's taking a wee while, but I'm glad you stick through it. We've just got a couple more questions. We're now on to 14b. Solve log base 2 brackets 7x minus 2 minus log base 2 3 equals 5. X has to be above 1 because you don't like doing logs with weird stuff like that, eh? Okay, well, let me just do a wee bit of stretching. This one seems a bit more difficult, don't you think? And, well, yeah, no shame in hiding it. Sometimes you do have to get a bit your hands dirty. But remember, we can apply same rules here. So if we added stuff and it multiplies the term, then if we take away stuff, then it will be dividing. That sounds good to me. So that means log base 2. I'll just write it out here. Equals 5. We can go straight away and say log 2, log base 2, I should say, sorry, is equal to 7x minus 2 over 3, right? Equals 5. And then we're going to do something amazing, folks. You're not going to believe this. We're going to convert this into that. This means if we move that log up to the other side, right? I'm going to move it from, oh my god, okay. Not what happened there. move this onto the other side. So this thing will be by itself. Will equal 2 to the power of 5. Huh? That's what happens when you move logs on the other side. Become exponentials. Or exponents, I should say. Sorry. All right. And this looks like an equation we can solve. So that's 32, right? And then 7x minus 2. And then we can just solve it algebraically from there. So I'll try to do a bit more horizontal, save the trees, you know. So 7x minus 2. I'm going to times both sides by 3. And that'll give us 96, because 3 times 32 is 96. Then add 2 to both sides. So that'll give us, I'll put a better comma there, won't I? Oh, that'll do. 7x equals 98. And you're just going to have to go over me on this. 7, you're going to have to know that if you divide 98 by 7, you might need to do the bus stop method or whatever you could call, like the like we always do, it's short division when you go stuff like that. But what I think of it is that 98, that's 70 plus 28. Divide by 70, you get 10. Divide 28 by 7, you get 4. So it'll be 14. And there's your answer. Let me just check. Oh my mod, I'm correct. Crazy. Right, last page. Whoa, we've made great progress so far. Glad you really stick through. And I'm surprised I've kept my sanity for so long. And this is where things start to get a bit wild, if I do say so myself. So, this one, I'll be honest, I actually got stuck on this equation for ages when I was practicing doing this for some of my maths homework. So, yeah, don't feel, if you look at this and just scream out in agony, don't worry, I've been there too. Right, solve the equation, sine 2x plus 6 cos x equals 0. Right, let's write this down. And it's a 4 marker, so it's a bit of a chunky question. Boom. Now, when in doubt, remember folks, formula sheet has the answers. And look at this. Sine 2a equals sine a cos a. So let's slot that in, eh? Plus 6 cos x equals 0. Now, where do we go from here? Well, it's a question I've often asked myself, but don't you worry, it's not going to be too horrific. Okay? So what we're going to do is we're going to divide we're going to take cos as out, cos x as out as a common factor, okay? And this will leave us in the brackets as 2. Oh, that's not, I didn't even write an S. I'm getting lazy by the minute, folks. That's an M. Oh man, oh man, oh man. We're sugared. 2 sine x plus 6 equals 0. And I've said like 3 times now, if you got something times something else equals 0, one of these has to be 0. So we can split this up. So, could be cos x equals 0, or 2 sine x, sorry I'm speaking really slow, equals 0 plus 6. Right. Let's do this one first, okay? I'm going to divide everything by 2, because then we're just left with pure sine x plus 3. I'm then going to move 3 onto the other side, and more astute among you will know that I'm running into a trap. Yeah, that's right. Sine x equals minus 3. Uh-oh, if you look at a graph of sine, you cannot do that. It's banned, because sine, regular sine, only goes up to 1. That's not a 1, that's a 1. And minus 1. Okay, so no solutions. That side is a dead end. would like to delete his own print jobs. These are cute for each print days. No thanks. Windows. Cos x equals 0. Maybe this will bear more fruit. And you would want to probably draw out the cos graph for this. It would just make things easier. So remember, cos does this. Yeah, beautiful, ain't it? But at 0, it's you want to find out when it crosses this line here. And hopefully you just remember this, because that's 90, that's 180, and that's 270, right? So it'll be 90 and 270. So you can say x equals 90 degrees 270. And there you go. That's your thing done. I spent hours on this. I just kept getting those solutions. I was a bit of a moron, wasn't it? But let's go and do B now. Hence solve sine 4x plus 6 cos 2x for this. So there's only one marker, so you don't actually will need to do too much. But essentially, what you're going to get with this is you're just going to get, here, you're just going to times by 2. You're going to have a 2 as a phase angle. So this won't change because sine does not, even if I increase the, if I increase the phase modifier on sine, I'm still going to not get any solutions. So we don't need to worry about that. So we can just go like, okay, well, it'll be just cos 2x equals 0, right? That seems good to me. So that means we can actually use our original solutions. But this time we need to divide by 2 because it will be timesing itself by 2. So we already know the first two solutions, if I can actually draw an x correctly, are 45 because you divide 90 by 45, you get divided 90 by 2, you get 45. And then when you divide 270, that's 135 because 35 times 2 equals 70. And then 100 times 2 equals 200, right? Okay, but remember, it's between 0 and 360. So we need to calculate some more solutions. Because if you look at I'll draw a quick graph where it's cos 2x, right? So it'll be going like that in 360. And we're looking for when it's 0. That's 1, 2, 3, 4 solutions. Oh no. Well, don't worry. We only need to count the first 2. And then we just add on the period of the graph. And because it's 2, instead of being 360, it's 180, right? Because it's moving twice as fast, if you will. So if we just add on 180 to these ones, we should be solid. So 180 plus 45, what do you think that is? It's 225. Scrumptious. And then add 180 onto 135, it's 315. Ain't that great? And that's it. That's a mark. Oh, and I think we'll have to make another paint file. Right, new paint file it is. Last 2 questions, folks. We can get through this. I swear. Oh, wow. It's been a long road, hasn't it? 16. A. I swear there's an A, not a U. The point P has coordinates 4k. C is the center of the circle of equation x minus 1 squared plus y plus 2 squared equals 25. Show the distance between points P and C is given by root k squared plus 4k plus 3. And it show that. So our final answer will be this, right? But we have to pretend like we don't know this, all right? We're just going to have to hit myself. We can't start out by using this to calculate anything. We have to use everything else we got but this. We'll end up with the answer. So it is a gift. It's a good question because that means you can check your answers. You just need to do your working correctly and you're sorted. Okay? Right. How are you going to figure this one out? Well, the equation here, we want to figure out C. And this is a really nice form for calculating circles. You should just be able to read it off from there. But just in case, I'm going to go up here and just kind of show it to you. So center AB, and it's just minus AB. So you just need to flip the signs, and that's it. Ain't that beautiful? Okay, so we can just say C equals, the center of C is 1 minus 2. Righty. Show the distance between points P and C. So we need to calculate the distance between P and C. And we already know that P is 4K. Okay. So the way we do this is there's a distance formula that everyone loves that doesn't remember. But I'm just going to say, can I please type in my box, please? That'll be lovely. Distance between, and I'll expand this out so you guys can actually see what I'm on about. P and C equals, move it up there, move it a bit down, I think maybe. Yep, that looks good. Move back onto brushes. Will be equal to this equation. It's going to look really nasty, but the distance formula is actually really simple. Okay. Oh, my God, these Y's, man. Why am I so bad at drawing Y's? Boom. Okay, yeah, I know, it's a wee squint, but hey, well, that's what you get when you chose to watch this video. You know what you were getting into. So we need to shove these fingers in. So you can just pick one of these coordinates. I'll go and write out the P. P is 4K, right? Just choose one of these to be 2. I'm going to say P is 2. So that means X of P, that's 4, right? Make sure it's surrounded in brackets. And then X of 1, that would be this. So 4 minus 1, all squared. Plus Y2, that's K. Cool, cool. And then Y1, that's minus 2. And then if we're minus here or minus here, sure, you know what that means. It's actually a positive. Crazy. So, 4 minus 1, I think that's 3, right? And 3 squared, that's 9. Okay. And this one, we're just going to have to do a bit more trickery. So, K times K, that's K squared, right? And then what's 2 times K? Well, that's 2K, right? But we also do that again, because remember, I'll draw this in red so you see what I'm up to. But this essentially equals K plus 2. Remember, when you square a number, you're timesing it by itself. So you're doing like this. So we've already done K times K, but then we do 2K, and we do it again, because this 2 comes back later. So it would be plus 4K. Good resolution, eh? And then 2 times 2, hope you all know that, that's 4. Okay, well, let's see if we're on track. That looks mighty close to me. So that's we're doing solid. All we need to do now is just collect like terms. So 4K, and then 9 plus 4, that's 13. Ain't that a miracle? That's great. And there we go. It's the same as a thing. We're all sorted. Yeah. We're done. That's it. All right. So B. 4 marker, so it will be a wee trickier. Hence or otherwise, find the range of values of K such that P lies outside the circle. Okay. How are we going to do this? So, lies outside the circle. So if I just I'll do a quick diagram of what's going on. So we have circle here, 2 centers for some reason. Pretend that that's center is C, right? We want P to be outside of it. The only way we can do that is vary the Y thing. So if P's over here, right, we want to make sure the Y is high enough that it's outside, or it's low enough that it's down here, not in the center. Okay, so how are we going to figure that out? Well, hence, which means that we probably want to use the answer we've been given to here. Okay, so see if an object is inside a circle. You need to calculate the distance between the points and compare it to the radius. When you're on the radius, that's r squared there, so the radius must be 5. So I'm going to say radius equals root 25. So that's equal 5, right? So we know the radius is 5. And then we want this distance formula here to be bigger than 5, so it's outside. So that means that root k, well, root k in the tab over, so root squared k, I should say, plus 4k plus 13 is bigger than 5. Okay, now we solve it. How are we going to do that? Well, firstly, let's square both sides. So we can get rid of this huge square root. So it would just be plus, it would be k squared plus 4k plus 13 is greater than 25. Cool. And then let's subtract 25 from both sides. That'll give us k squared plus 4k minus 12 is greater than 0. And we've got a quadratic inequality. Oh yeah. So, when we do this, we're going to factorize just like usual. So we need to find numbers that multiply to make minus 12 and add to get minus 4. And 12 has got loads of different factors. So let's just have a wee think about that for now. I'm thinking 2 and 6 sound good to me, right? Because if you have minus 2 and positive 6, minus 2 plus positive 6 will get you 4, but it will make you minus 12. So let's throw that in, eh? Over 0. Cool. Right. Then what we'll do here is we'll draw a graph of this equation, right? Because we figure out the zeros. So this means that. So we're going to draw a graph here. Now, in a previous life where I flipped this up majorly, remember the zeros here would be k equals 2 and k equals minus 6. Don't want to do what I did previously when I did it the other way around and it was really bloody embarrassing. Oops. So that'd be minus 6 there, and that would be 2 there. Doesn't really change well, it does change the answer majorly, but shut up. We want to find an area that's not in this center bit here. It's sloping up a smiley face parabola because it's a positive, so there's no minuses there, right? So we need k, if it's going this way, right, it needs to be less than minus 6. Okay, so that'll cover this whole other side of the graph here. But we also want this bit here. So that means k could also be greater than 2. There you go, and that's your answer. And very last question. It's been a while, hasn't it? It's 17a. 3 markers, so it shouldn't actually be that bad. Express sine x minus cos x squared in the form p plus q sine rx, where p, q, and r are integers. Oh boy, what are we gonna do for this one? Right, let's get to it after that wee jump cut. Write down what you're gonna do. And I think we can already start expanding these brackets. So let's do that, eh? So that would be sine x times sine x, that's sine squared x. And then it's, remember when we're doing this sort of thing, it's sort of writing this. It's the number times itself. This would just help you. I'm just doing do this just so you help I kind of visualize this, because I do get that maths is kind of the thing that's quite difficult to picture in your head sometimes. Beautiful. Well, not beautiful. So we've done sine x times sine x. Now we're going to do minus cos x times sine x, and we do it twice, you see, because there's 2 ways to do it. So that means you have minus, that's in red, don't want it in red, minus 2 cos x, nope, sine x. This looks familiar, doesn't it? We'll come back to that later. And then minus cos x times minus cos x. Well, that's just positive cos x squared. Cool. Okay, well, I'm noticing a few interesting details about this. Let's shift some stuff around. This will help you figure it out. So you're going to have to think back to N5 for the solution to this one. I have done I probably should have written the sign first, but whatever, I live on the edge, I'm a rebel. So, there you go. Now, you might have, in N5, you might have come across the formula, sine x, it's more of our identity, but cos x squared equals 1. That's supposed to be squared, not a 2x, right? I know I've spoken to a lot of people, they have like never covered this, but basically we can simplify this whole bit here as 1. They really should. They don't do a very good job teaching that, which is a shame because it's very useful. Well, okay, very useful is not the correct way to put it. Very unuseful, but it is important, right? So this is already looking amazing, and if we've seen this before, don't want to scroll up there, do I? 2 cos x sine x. That looks very familiar, doesn't it? So it's just minus of sine 2x. Yeah. Oops. Just cleaning up some nonsense there. That's looking brilliant. Way simpler than our complicated thing we had before. Oh, excuse me. But we wanted in this weird form here, where these are integers, but it looks like we're already there, actually. Because, well, p equals 1, right? Q, that's minus 1. And then R, that's 2. And these are all integers, because integers are, like, non-fractions, you know? They're all whole numbers, I guess, right? So we're already there. Ain't that fantastic? And now, final question, only 2 marks. Hence find the derivative, not the derivative, the integral of that. So I'm just going to quickly write this all out. It's supposed to be sine x first, ain't it? This is an indefinite integral, so remember your plus c. And please, please, remember your dx. I've kicked myself so many times. I've lost like so many marks from just not writing those two letters. But we can substitute in. We already figured out what this is. So it would be 1 minus sine x. 2x, sorry. Whoops. And dx. I'm just going to continue hammering that home. Please remember your dx's. So, well, what we're going to do here? Well, it looks all good to me. They're all in order. So what's the derivative of 1? Well, it's x, ain't it? Right? Minus sine x. So this is where things are a bit weird, but remember, it's not on here anyway. When you draw a quick diagram, to integrate, you just go the other way. So you go from minus sine x to cos x. Well, ain't that helpful? Aha, but there's one thing you do need to do. Remember, 2x, that's as in brackets. So we need to do the chain rule. And we need to divide this by 2. And don't forget, indefinite integral. We don't know the limits. We need to do a plus c. And I don't know why my Discord is going. Cheers, mate. But yeah, that's looking good so far. And it's the correct answer. So there you go. That was the entire non-calculated paper of the thing. I really hope you enjoyed. Well, I mean, if you probably don't enjoy it, I get maths is not a favorite thing, but I hope you learned some stuff. I have probably made about 5 peculiar mistakes. Can that person please shut up? What an inopportune time to do it, but I'm sorry. um, Hope you've all learned some stuff. I've made loads of mistakes, so please comment down below. And I'll leave the links to the overall papers so you can do them yourself and follow along with me in the description. Probably should have said that at the start. But anyway, cheerio, folks.